You installed Ollama, downloaded Llama 3, ran your first prompt locally. It worked. You felt good. You called it your local AI stack. That is not a stack. That is a model sitting on your laptop with no architecture around it. And that single mistake of no architecture is what most AI developers make. It works fine until it doesn't. Memory leaks, no context management, models crashing, queues backing up, zero observability. The model was never the problem. In the next 5 minutes, I'm going to show you exactly what real architecture looks like. Here is what most people build. I call it the naked model setup. Your app talks directly to Ollama, no queue, no rate limiter, no context manager, no memory layer, no health check, no fallback, no observability. Everything flows through one pipe. When two users hit it simultaneously, it locks. When the model loads a new context, memory spikes. When it crashes, your app crashes. 5 problems, all from the same root cause. You skipped the architecture layer. The real architecture has exactly 5 layers between your app and the model. Each layer solves one of the problems we just saw. Layer 1, API gateway. Rate limiting, auth, routing. Nothing hits the model without going through here. Layer 2, request queue. Redis or similar. Serialize concurrent requests. No more deadlocks. Layer 3, context manager. Sliding window tokenizer. Trim history to fit the model's context window. Layer 4, memory store. Redis for short-term, vector database for long-term. The model remembers across sessions. Layer 5, health monitor. Watches the model process. Restarts it on out of memory. Exposes a /health endpoint. That is the stack. Now, let me show you each one in code. Every request hits FastAPI first. 3 jobs, rate limit, authenticate, root. Slow API gives you rate limiting in 2 lines. No rate limiter means a single bad script can hammer your GPU into the ground. Always put a gate in front of the model. The queue is the most important layer. It turns concurrent chaos into orderly serial processing. Redis with asyncio. Each request waits its turn. The model never sees 2 requests at once. Add a timeout. If the model takes more than 30 seconds, reject the request early. Context management. This is where most tutorials completely fail, and where you bleed performance. Every model has a context window. Llama 3 is 8,000 tokens by default. If you pass the full conversation history, every call, without trimming it, you're processing 10,000 tokens when you only need the last 2,000. Use a sliding window, keep the system prompt, keep the last n messages, summarize the rest. 2 types of memory, short-term and long-term. Short-term, the last 20 messages. Stored in Redis, expires in 24 hours. Long-term, facts, preferences, summaries, embedded and stored in ChromaDB. Before every request, retrieve the 3 most relevant long-term memories and inject them. This is what makes your local AI feel like it actually knows the user. The last layer is the one nobody builds until something breaks in production. Watch the Ollama process memory. If it crosses your threshold, restart it gracefully. Expose a /health endpoint. Prometheus scrapes it. You get alerts before users do. Now we wire all 5 layers together. This is the file your production local AI runs from. Request comes in, gateway checks rate limits, queue serializes it, context manager trims history, memory injects long-term facts, Ollama generates the response. Memory saves the turn. Response returns. This is the architecture, not running Ollama in a terminal. The complete code is in the GitHub repo below, ready to fork. Here's what the architecture actually does to your numbers. Before a single user, First response in 2.4 seconds, crashes at 3 concurrent users. After 10 concurrent users, 1.1 second response, 0 crashes in a 30-day test. Same model, same hardware, same GPU, different architecture? The model was never the bottleneck, the missing layers were. About 220 lines of code. That's the difference between a toy and a system. Layer 1, gateway. Rate limit everything. Layer 2, queue. Serialize concurrent requests. Layer 3, context. Trim to fit the window every time. Layer 4, memory. Short-term Redis, long-term vectors. Layer 5, health. Watch the process. Restart on out of memory. The full fork-ready code is in the GitHub link below. All 5 layers fully documented. If you're building with Ollama, N8N, or LM Studio, this architecture works with all 3. Subscribe. Next video, adding a streaming response layer and a local embeddings pipeline.